AI innovations in the automotive industry, BMW Group. Well, we've got with us the speaker, none other than Matthias Schindler, who's the head of AI Innovations BMW. Mr. Schindler specializes in artificial intelligence, machine learning, data analytics, quality, and manufacturing, having also won the Pioneer Award for the Auto Build and Computer Build 2020 for AI at production. So firstly, a huge welcome and thank you so much for joining us today. If I may request you to kindly unmute yourself and put your video button on.
Hello, thank you very much for the introduction.
Pleasure.
I hope you can hear and see me.
Yes, we can. Thank you.
Great. Yeah, so thank you very much for the invitation. Today I have the chance to give you some insights about the BMW production system, where we already have first AI applications running, and hopefully this can give you an idea how it already can work and what's in AI, especially within the manufacturing context for you. So I will start sharing my screen. So I hope that you can see my screen also. So I've prepared some slides giving you a overview about the AI innovations we have here at the BMW Group in many of our plants worldwide. So as you mentioned in the introduction, I'm responsible for all the AI innovations in the BMW production system. And of course, with our production system, we focus on these products. It's our goal to integrate all the different types of powertrains into one, especially assembly line. So this is for us really crucial, and hopefully you can get a better understanding. That means that we produce petrol cars, diesel cars, already hybrids, and in the very near future also fully electrical cars on the very same line, which will bring, of course, a little bit of complexity into the BMW production system. On the other hand, that offers us the flexibility to respond in the very correct manner onto the specific market demand, which is, from today's point of view, pretty hard to predict. So I brought some key figures about the BMW production system. At the moment, we're producing around about 55 derivatives. We have 31 facilities in 15 countries spread all over the world. Around about 50,000 direct employees in production, so 50,000 employees in manufacturing, around about 20,000 robots, and we're handling around about 30 million parts every day. This is really crucial for us. On the one hand, individualization plays a very important role, which means we have to manufacture every car in the very exact manner our customer has ordered it. And of course, on the other hand, individualization plays a very important role for all of our customers. So 7 out of 10 customers are individualizing their cars. Giving you an idea what this configuration can mean. For example, with the actual BMW 3 Series, you have more than 1 billion possible combinations within only this type of car. So having in mind that we try to integrate all the different types of derivatives, all the different types of powertrains onto the same assembly line. That means, for example, for one of our German plants, we could produce cars for 107 years until the same configuration has to come once again. So this gives you a little bit about what complexity means, what the individualization of cars means for us at BMW. So today's topic should be AI, or artificial intelligence in general. So when it comes to AI, we typically use deep learning, which is described here in a very brief introduction. First of all, we always have to train a model, or model a neural network, so to say. Therefore, we record images. Afterwards, we label them, and then this is first of all we have to do manually. Afterwards, the model will be created inside the computer. So this is more or less where the intelligence comes into play. So the computer tries to optimize the neural network that it fits best onto the recorded training data set. Afterwards, we deploy the model, then we test it, and if it's sufficient or good enough, so to say, we can bring it into live production. If it is not, we try to improve the model, which typically means to us, from a production point of view, we take some more pictures, we label them, and then we rerun the process. In the productive phase, we typically need a trigger. So, for example, in Europe, we don't take video streams, but we typically work with pictures only. So we want to ensure that every car will be detected. Afterwards, the AI will give us the detection. In a few minutes, we will see some examples how that would look like. Afterwards, we match it with the target configuration. So that means the AI only gives us the result. What is the exact component that has been, for example, assembled onto a car? And afterwards, we map it with the target configuration, for example, via the vehicle identification number. And then we see in the result if that is okay or not okay. Of course, we want to note the result, especially in not okay case. So we write it into a database. And of course, no car with a not okay component will leave our plant. So this will mean rework if there's something wrong. I brought one example, which we call the type plate, which is pretty complex to us. On the one hand, here some pictures can be seen. We have more than 47 different features for this type plate. So that means 47 more or less derivatives run on this line. In the end, that means, for example, you can have the type plate such as M5 competition, M760i, and so on. So there are many, but not all of the examples given. And in the past, we had one employee in the production which was only responsible for checking if the type plate is the correct one. So that means, of course, 7 Series have to have a 7 Series type plate. But of course, some customers do not wish to appear any kind of type plate in there, which means in that case, we need to ensure that there's no type plate and so on. So in that case, it is pretty hard to automate that kind of task. On the other hand, our employees are not pretty happy if they are only checking 8 hours a day, which is the type plate given and is it the correct one. So this is one of the reasons why we started with our AI initiative in that very respective use case. So I have prepared a video showcasing the entire setup. So starting with the gathering the data set, labeling it, and then training the AI. Here we will see the video, which is imagery out of our plants. When we want to set up an AI, we first take some pictures. We typically try to collect pictures in a heterogeneous way, which means different colors, different angles, different focuses, as you can see here. So we take the pictures, around about 100 pictures per feature. After that, we label them. That is what can be seen here. So we annotate these bounding boxes for every of the picture, for every of the features. And then afterwards, having acquired enough data, we train the model, which then brings us into a very flexible system, as can be seen here. So the production can run, no stopping of the cars or thing like that. And we will have a live recognition of that type plate in that case, which on the one hand makes it much more convenient for our production workers, and the other hand, which is a much better quality recognition. So in the next slide, I have prepared some of the results, which can be seen here. This is a live picture out of our production. So in the lower left corner, you see in that case a BMW 3 Series Gran Turismo. And having a look at the pink box in the upper right, we see that there's a type plate given. The AI tells us, oh, that is the BMW 320i. And we see not only that it's the 320i, but also what we call confidence. Confident in that case is we are far beyond 99.99 and so on %. So we can see two effects. On the one hand, we have a very high confidence. We see what is the next possible solution, which would in that case be 320D, but only 0.00 and so on %. On the other hand, if you have a look at the upper right corner, we see the live image, and that would be pretty tough for us as a human being to identify what is the exact type plate given. Even though I'm wearing my glasses, I would not be too sure about that kind of type plate given. So this is why we believe in many cases to be beyond human parity. So in that case, an AI or in that special solution, the neural network can even be better than human beings, for example, in that kind of object detection task. So as seen in the video, our real production workers can aggregate the initial training data set, which means we designed the solution in a way that AI comes at the shop floor. So there is no data scientist going into production and doing that kind of modeling task, but our real production workers, they are taking the pictures, and with the help of our BMW labeling tool, which you could see in the picture as well, they are capable of doing the labeling task by their own, which also means they are capable of performing the entire AI setup process, if we want to call it that. And in the end, with around about 100 pictures per feature in that case, we are able to set up a very high robust solution. So after the initialization phase, so after the training of this deep neural network, we checked every car for 1 week of production, and there was not one single error. So that means today AI can be really helpful and really robust. On the one hand, even better than human beings are. On the other hand, pretty flexible when it comes to that kind of object detection tasks that can be automated. That finally brought us into winning the Connected Car Award, which is an award from Autobuild and Computer Build, two well-known newspapers here in Germany. And you can see me and my boss here in Las Vegas, where we received the award. The jury, and it was the jury prize, they said on the one hand, they think it's a very innovative solution for production, but on the other hand, they gave us the award because they thought it would be game-changing to really bringing AI and onto the shop floor. So really encouraging on the one hand the production workers to use AI, and on the other hand to design solutions in a way that you don't have to send them to university for years or months to turn them into data scientists, but to have easy to use solutions that can be used right without any training effort. So AI in the self-service. Of course, you don't only have AI solutions. You could use conventional computer vision, which has been figured out in here. Our major advantages we believe in AI is, on the one hand, in traditional camera booth or conventional computer vision, we typically have our cars stopping, which would be an interaction of the flow. On the other hand, all the conventional algorithms would be pixel-based, which is either demanding for very strict environmental conditions, or in the other hand, high effort for the initialization and stabilization. So there will be really experts either really programming these pixel-based approaches, if it's possible at all to stabilize these kind of conventional computer vision systems. So this is why we really believe in AI, and we have seen a first case with the type plate, but I have brought some more cases here, a pretty difficult to automate solution from the press shop. Once again, a little video showcasing that AI solution. In that case, we see a pillar reinforcing, which is done via 6 press steps. We have 1.7 seconds cycle time, which is pretty short compared to assembly, where we have much more than 60 seconds. And in that case, we want to ensure that there are no micro tears. So this solution has been set up many years ago, but in the conventional computer vision method, there were some insufficiencies. So we call it pseudo nut case or pseudo errors, and especially oil or dust particles or metal particles on top of these sheets, they were producing pseudo errors. And with that in mind, we started once again our AI solution. So we took pictures, 100 pictures per feature, so 100 of parts that are okay, 100 of oil, 100 of dust, and so on. Then we labeled it, which you can see here. So once again, our production colleagues, they are labeling it. In that case, this is one of my colleagues from Plant Dingolfing. He's quality expert for a very long time. So he's pretty familiar with the case, and he was doing the labeling by its own. Afterwards, we see here a 100% robust solution. So all the parts can be detected in the correct way, and what is on top is the live control of the robot. So when there's some error be detected, the robot can place the part in a dedicated way, and afterwards the parts can be thrown away, which in that case would mean we would only throw away parts that are really damaged parts, no pseudo errors any longer, which is pretty powerful. Once again, the logic is not to bring data scientists into production and doing some fancy AI stuff from a strategic point of view, but it's our overall goal to really bring AI to the people. So bring AI to the shop floor, that our production workers are capable of using AI systems. So summing it up, first of all, we always have the training phase. So what we encourage our production workers to do is take pictures. If it's a pretty easy use case, rather 100. If it's a harder use case, rather 1,000 images per feature. The initial data set should be diverse with respect to lighting, perspective, and so on. Afterwards, we do the labeling. As I mentioned, we have the BMW labeling tool, which is a dedicated labeling tool, pretty easy to use, very intuitive, and a small set of features. Afterwards, we can create the model with the help of almost any architecture or any framework we don't have any favorite from a production point of view. And then we start into the production phase, where of course the integration plays a role. We have to have the hardware in there, process will integration and software operations. In the end, that would mean AI is already available. It can be designed in an easy to use way, which is our overall goal. So this is why we decided to really develop our own software for specific parts of the whole AI training phase. But we did not only invent or develop the software, we also want to share it. So of course, open source in general plays a very important role when it comes to AI, and especially AI frameworks and architectures. Then this is why we decided to publish some of our algorithms already in late 2019. And last week we even did some more of a publishing. So we brought, for example, the BMW labeling tool onto GitHub. So whenever you're interested, feel free to download it. We believe in a very easy to solve, easy to use solution, which is capable for production workers to use in a self-service without training phase or without going to university. And this is what we believe in. So whenever it comes to innovation and technology, we at BMW Group, we believe technology needs to serve people, not only with AI, but with all kind of digital or other innovation. And this is why we set up the AI cases as shown in here. So our overall goal is technology serves people. So we brought AI to the shop floor, to our production workers in a very easy to use self-service way. But we didn't only bring it onto the shop floor, but also available for the entire world. So whenever you're interested, go to our GitHub site and have a look at our open source code project. Feel free to download and further develop all the code. So that should be a short introduction about AI at the BMW production system. If you have any more questions, please feel free to ask, or if you have questions later on, don't hesitate to contact me via the given channels. Thank you very much for your audience.
Thank you so much. That was incredible. And it was great to know what is happening out there. And once again, a big, big thank you, Matthias, for joining us today.